Hey, it's John at Gatti's Garage. Today we're going to waste an ungodly amount of time making a seat pivot. Hang out to see our struggles. Good morning, everybody. Back in the shop today. Back on the panhead build. Not really sure what I'm going to do on it today until I kind of get out there and get looking at it. Possibly work on the seat hinge so we can get the air ride set up for the seat buttoned up. I really don't know. I'm kind of drawing a blank as to what I want to do on it today. So anyway, I guess we'll just hop out there and get to work and get done what we can get done. So thanks for being here, and I hope you guys are enjoying following along. Alright, so we're out at the bike and decided we're going to work on the seat hinge. Pretty much every commercially available seat hinge I see, well, it sucks. So, because we're doing the air ride seat, I felt it was critical that the seat hinge be number one, strong, and number two, work well as far as pivoting. Otherwise, what's the point of having the air if the air ride seat doesn't operate smoothly? So I went to McMaster Car, one of our favorite suppliers, and we got some sealed needle bearings, piece of drill rod, and some shoulder bolts. With this stuff, I'm going to make a seat tee that actually pivots well. So first thing that we need to do is make the pivot block. So this old piece of tubing that they had welded on here will get ground off. We'll smooth that out. And we're going to make a bearing block to press these two bearings in. That will allow our piece of drill rod and then eventually our shoulder bolts, once we machine all this stuff, to fit together and have a bearing pivot seat tee. So first thing we got to do is get our block made up. I am going to grab a piece of material and then we'll measure up some dimensions and figure out exactly what we want to do for that. Alright guys, so we're over at the lathe. Decided to use a piece of 1-inch cold rolled to make our pivot. So first thing we got to do is figure out how long we need it, which is basically the length of these two bearings. So the bearings are like 1-inch 560, or I'm sorry, just 560. So we got two of those. So we're going to be like a 1-inch 120. So I'm going to quickly cut off a piece of 1.25 long. Get a little scribe mark. We'll cut this off on the bandsaw, come back and start doing our machine work. Alright, so we got our piece. First thing we're going to do is get it faced off. We'll flip it around and then machine it to our finished length. Alright, we got our piece machined to length. Next thing we're going to do is center drill it and drill it for our bearings. But what I want to do is offset that hole a little bit. Being that it's not a precision offset we really need, just clamp a piece of 1/8 inch stock in one of the jaws, and that gives us our offset easily without having to change to the 4-jaw chuck and dial in a big offset and all that. So just kind of a quick, easy way to do it. Alright, next up on the machine process is we're just going to quickly put a small flat spot on the bottom of here so it'll locate on our frame for welding. Alright, we got our nice flat spot. If it'll focus. There we go. So we'll deburr this, go press our bearings in it. Alright, so I'm going to go ahead and press our bearings in. These have a sealing O-ring on one side, so clearly you want to make sure if you have that type of bearing that you're pressing it in from the outside. One other thing that occurred to me, I had put the bearings in here, and it occurred to me that with the rubber seals in there, welding this piece on with the bearings in place was not going to be a good idea. So I went ahead and pressed them out. I opened this clearance up, so it's just basically a size on size slip fit. It's a little bit loose for a press, but it'll allow me to just squeeze them in by hand, and I'll use some Loctite sleeve lock, which is a perfectly acceptable way to do this, and I don't have to worry about the heat damaging my bearings when I weld it to the frame. So just wanted to mention that before we go draw up these seat hinge parts. Alright, so we're going to draw up our seat hinge. Should be a relatively simple part. I'm going to go ahead and draw up a couple of rectangles. We're just adding some fillets to the corners here. Nice radius part. This will be the rectangle that ends up getting bent into a C-channel to fit on our pivot. Next we're going to put our pivot holes. These will actually be put in just to mark the holes. Use an undersized dimension. In this instance, using a 1/4 inch hole. Once the part is bent, they'll be drilled out simultaneously. Next up, we're just going to draw another rectangle, which will end up being our seat mounting tab. I draw this individual from the other part and then use my pointer to drag it over and drop it right in the center of this piece. Once that's done, we can trim out the center, and that'll leave us with one uniform piece. Alright, so we're back on this CT again. This is now my third attempt. I don't always get it right the first time. I'm not always happy with it, and I never hesitate to throw something out if I don't like it. So we're laying our pivot boss on here. And we're marking our bend lines. And the press brake is just really not giving us the bend we want. It's a little bit too tight of a bend. The jaw kind of gets in the way when you do the first bend. So I'm going to switch over. I have this little vice press brake. Which, as you can see, I have not used in forever. It's filthy dirty. But I'm going to try and use this to get them started at least, and then it's just a much sharper blade, if you will, or die. So I'm going to line my mark up on there. And use this to get it started, and then I think I'm just going to clean it up in the vise with the hammer. So that's about as far as I can go with that. And now I'm going to try and squeeze it down. Alright, so we got our U-shape bent up here, which, you know, honestly, I'm kind of still debating if I'm happy with. I'm wondering if I'd be better to fabricate this. I don't know. I guess I'm going to plug on with it and then I'll decide, but nah, I don't like it. Scrap bin, and we're going to come up with something else because I'm just really not happy with how that's going. I think what I'm going to do is go ahead and install the pivot on the frame, get the bearings in, and then I think I'm going to fabricate a piece from steel. We'll weld it up. We'll be able to grind it. Might actually make it out of aluminum. Now that I'm thinking this, I can make it out of some 1/4-inch aluminum, weld it all up, blend it, and polish it. It'll look really nice. So that's my plan. So go ahead and get the pivot installed on the frame. We'll get the pivot bearings in, we'll get the pivot pieces all machined up, and then we can take a look at how we're going to solve this problem we've made for ourselves. Alright, so we'll let that cool, we'll put our bearings in it, and then we'll calculate for our bearing inner race. Cut that, machine it, and all that good stuff. Alright, so we measure up our cross piece, which is 1 inch 200. And we're going to use 1/4 inch aluminum for our CT. I'm going to fabricate that, I've decided. So that's another 500. So we have 1 inch 700 total width. Now we have these shoulder bolts here that have a 205 thousandths shoulder. That'll give us 5 thousandths on each side, of a total of 10 thousandths gap. If we call them 200, take 400 thousandths off our total length. We need 1 inch 300 thousandths for our piece of center spacer, in addition to the 200 on each shoulder bolt, will give us our 1 inch 700 thousandths dimension. So I don't know how many people followed that or how many people care, but basically what we're doing is we're making the inner bearing race a little narrower than you would if you used a standard bolt, and we're using a shoulder bolt. I just think it's going to make it a little stronger. So point is, we're going to machine this piece of 3/8 drill rod, drill it, tap it, and then we'll have a 1 inch 700 thousandths total length inner bearing spacer, which will fit on our lug we just welded to our frame and account for the 1/2 inch added material, 1/4 inch on each side of a hand fabricated aluminum seat hinge. Alright, so we faced off, we zeroed our x-axis. We're going to come here and measure now. We've got 1 inch 607, so we need to remove 307 thousandths. Alright, there you have it. See if you can see this a little bit better. Some light. We got our pivot bushing, or our pivot bearing inner race with our locating shoulder bolts. One other thing is these bolts have some ugly serrations on the heads and marking, so we just can't have that. I'm going to go ahead and cut a nice little detail on these and get rid of it. Alright, there you have it. Nothing too crazy, just a nice little simple taper. Cleans up the bolt. Maybe, if we can get any. There we go. So still needs a little sanding and polishing, but looks better than a factory bolt. Alright, we got that nice and cooled down. We got our Loctite 603 retaining compound. I'm going to put it on these bearings. Slide them in here, and once they're in with this 603, it'll be pretty difficult to get them back out. Alright, let's try that again without dropping them. Clean all the junk off. course, now that I've welded it, looks like my hole snugged up a little bit, so we'll use a C-clamp. As a sort of little press, and it ought to suck them right in. Alright, so first one's in nice and flush. A little compound on this side. Probably got a little burr on it when I press these out. There we go, and that one slid in by hand, so the retaining compound will be there to do its job. Alright, there you have it. Got our pivot race and our seat pivot with needle bearings. So there you go. You can see our gap here where this can move side to side is what will allow for the seat hinge, I guess we're calling it. I keep calling it a seat T because that's what the old Pogo seat Harleys used. So it's a seat T or a seat hinge or whatever. We're going to go ahead and fabricate it up out of some 1/4-inch aluminum. We're actually going to make a drop in it right here because being that the air ride seat, I want the seat to sit flat, and then when the air pops up, it'll raise this up. So it's going to be a little bit of a bizarre seat hinge to begin with, and that's why I was not happy with the steel fabricated, bent fabricated ones. They just weren't coming out how I wanted, so I ditched them and chalk it up as a learning experience and keep moving forward. So really happy with this. It doesn't probably seem like very much was done, but building a part like this with precision, with these almost press fit holes and clearances so that we have zero side to side wobble and it's only going to pivot, it's a pain in the ass, and it's really super time consuming. So anyway, it's something I enjoy doing. I'm glad to have the opportunity to do it on a bike. Normally there just isn't time or budget to work on these bikes with this amount of detail, but every now and then we get to do one and just take it to the extreme. All right guys, we are out of time for today. Did not get much accomplished today. Well, that's not true. We got a part made. It's just a super time consuming part, and the second piece of this puzzle is also going to be really time consuming, and that's why I kind of scrapped the idea of just bending one up. Like I said, it was flimsy. I didn't like anything about it. It was not going to carry the level of precision and quality work we're trying to turn out on this bike. And so we junked it and moved on. We got our pivot done, our bearings are in place, our inner race, machined our bolts, all that stuff's ready. So next week we will have the time to dedicate to just building the hinge / seat T, whatever you want to call it. So anyway, I hope you guys are enjoying this bike. It's a really cool bike, and the amount of time I've been lucky enough to be able to spend on it makes it really exceptional, and I think will end up being one of our nicest bikes. Like I said earlier, rarely do we get to spend the amount of time that it takes to really build a highly detailed bike. There just isn't time or budget or all kinds of different things that go into it. So this bike, I'm basically getting to do whatever I want on it. And so I'm taking the time. There's no big rush on getting it done. And all of that will show in the end in the quality that we turn out. So thanks for being here, and we hope to see you next time at Gatti's Garage.